This video, I'm going to talk about finding the confidence interval using your calculator. And there's actually two methods to find a confidence interval using your calculator. One is called the data method, where you use data that's given to you in a problem. And the other is called the stats method, where you use the actual statistics that are given to you in a problem. You know the difference between data and stats because of the way you enter the information. In the data method, you're going to use the list. In the stats method, you'll just pull the numbers from the problem. So we're going to use a new function that's located under the stats button. And so if you hit your stats button like this, and at the top of your screen, you should see a menu that says Edit, Calc, and Test. And we're going to start using our test menu now. So at the top, you're going to hit Test like this. And it's going to bring up all these different tests and intervals. We want to focus on a t interval right now. So we're going to focus on the t interval, which in my case is number 8. It may be 8, it may be 9, but it should be somewhere around there in your list as well. So you're going to find the t interval, and we're going to talk about what the t interval looks like. So your t interval will look like this one on my screen. My calculator is a emulator, so it doesn't look quite like yours, but it does the same thing. And the way the t interval works is you can either pick the data method or the stats method. For this problem, it says you randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days with the sample standard deviation of 2.39 days. Construct a 95% confidence interval for the population mean number of days the car model sits on the dealership lot. So when I talk about this, I'm using a t interval here. And I'm creating, it says construct a 95% confidence interval. That's how I know I'm doing an interval first off. It's the t interval because they've given me this sample standard deviation here. They tell me that's 2.39 days. So anytime I get a sample standard deviation, I use a t interval. And what I'm going to do now is with this information, I'm going to list out the different variables they've given me. And notice here, I need to have first, I need an x bar. Remember, x bar is the sample mean. So they told me that in this particular problem, the sample mean is 97.5 days. So my x bar is equal to 9.75. Then I need S of X. Well, S of X is the sample standard deviation. That's located here. So S of X is equal to 2.39 days. And then the next part says the n, the sample size. So my sample size, well, I've randomly selected 36 cars. So my n is equal to 30. I'm sorry, 36. And then the final thing is they need a confidence level. Well, the confidence level in the problem was given to me to be construct a 95% confidence level. So you're going to always express the confidence level as a decimal. And here it's already written as 0.95. So just for reference, when we create a confidence interval, remember a confidence interval is based off of some sample value that is used to estimate the population value. So when we start a confidence interval, in this particular case for the mean, for the population mean, we're basing it off the sample mean x bar. And what we want to do is we want to put errors on both sides of x bar. So essentially what's happening here is we're looking at a normal curve like this again. And on that normal curve, we want the mean to sit in the middle. And this is the true value mu that we're trying to pick up. But we're estimating it with x bar. And we're going to put error around x bar. So we're going to put error on this side and on this side of x bar. Same amount of error. Remember, we call that error E. So this is basically this right here, and this right here is what we call the margin of error, E. This is actually negative E, and this is plus E. So you can see that to create a confidence interval, it's just some statistic, either minus E for the lower bound, and this is called the lower bound, and this is called the upper bound. So the lower is x bar minus E, the upper is x bar plus E. We can simplify that by writing it as plus or minus, and we know this is E. And if we go back real quick. We know that E, the margin of error, is equal to this right here, Z star times sigma x divided by the square root of n. Now, we only use this formula, though, if the standard deviation is known. And that's because we're using the Z variable. In this problem, though, it tells me I'm using a sample standard deviation, which means the standard deviation is not known, and I need to use the T variable. So here's how we change the actual standard deviation, or the actual margin of error. X bar plus or minus, E is now going to be written as, instead of calling Z star, we're going to use a critical value, T star, with its degrees of freedom. And remember, degrees of freedom are always based off of the sample size n minus 1. And we're going to do T star with its degrees of freedom times the standard error. The standard error for T star, we talked about that right here. This value is the standard error now, the new standard error that we have created for T star. And remember, we introduced it here. We said that we're making this, we're estimating sigma, so that's why we're using S of x now. And the standard error is always the standard deviation divided by the square root of n. So in the central limit theorem, we saw it was this based off of Z. We don't know sigma x anymore, but we're using its estimate, S of x. So coming back then, this would be T star degrees of freedom times S of x over the square root of n. And so literally we could plug this into a calculator just like this, 9.75 plus or minus. I need to find T star with its degrees of freedom. And that's the critical value. So remember how we find critical values. To find T star, the degrees of freedom here are going to be equal to 36 minus 1, which is 35. So I need to find the critical value for this. T star at 35 degrees of freedom. So again, I draw a curve. On the inside of the curve is 95% of the data, which means 5% on the outside. So to find this T star here, I do inverse norm. And here's how I do this. Remember, this is 2.5% to that side. So I'm going to add up this 2.5% to that to 95%, and I get 97.5%. And now the degrees of freedom are 35. So in my calculator, and some of you may or may not see this, depending on what calculator you have, but if you have a calculator like mine, or if you have a TI-84, you should see this. And so you're going to go to you go to second and you go to vars, second and vars. And you're looking for the inverse T. And I put inverse norm, but this should actually be inverse T because we're talking about the T distribution. This should be inverse T. So inverse T, 0.975, comma, 35. And here's what I get. So my T value is 2.03, round to 3 decimals, 2.030. S of x, my S of x, or the S here is 2.29. And the divided by the square root of my sample size, which was 36. So I can type this into my calculator just like this, but I have to do two calculations. I have to do a positive calculation and a negative calculation. So the first thing I'm going to do is actually calculate the margin of error, E. So here is E. I'm going to calculate that first, 2.030 times 2.29 divided by the square root of 36. And I get this value here, 0.77478. So the margin of error here is basically 0.774, we'll call it 8 like this. So I'm going to add 9.75. I'm going to subtract 9.75 from 0.7748. And I'm going to add it, 9.75 plus 0.7748. And this will give me the upper and lower bounds for this particular problem. So if I do 9.75 minus 0.7748, I get this right here. The lower bound is 8.975, and the upper bound 9.75 plus 0.7748 is equal to 10.523. So there goes the upper and lower bounds. Now, this is doing this by hand, which you need to understand the concept behind doing it by hand. And what you're doing is you're placing the mean in the middle and adding error to both sides. And the error is called the margin of error. The quicker way to do any one of these problems, though, is going to be using the calculator and using this particular function, the t-interval. So again, to draw up the t-interval, we'll do it like this. We'll press second, then we'll press stat. I'm sorry, just press stat. So press stat. You're gonna go to your menu at the top. You're gonna go to test. And on test, you can look for number 8, which is t-interval. And t-interval is gonna ask you for certain things. First, I was gonna ask you, do you wanna do data or stats? Well, did we put anything into a list? No, we pulled everything from the problem. When you pull everything from the problem, that means you're always gonna do a stats problem. So we're gonna make sure that this is highlighted on stats. And mine is highlighted on the stats down here. And then the first thing it asked me for is X bar. Well, my X bar here was 9.75. The standard deviation was 2.29. And the sample size was 36. The last step is to set the confidence level. And the confidence level will always be expressed as a decimal. So we'll say the set is 95%. When you set your confidence level, you will type in 95% to the calculator. The calculator will do all of this t-critical value stuff for you. It doesn't need you to put in 0.975. It wants the actual confidence level from the problem, which was 95%. So I'm going to type in 0.95, and I get this right here. And if you look over at my lower bound, it tells me, and yours will spit it out too, yours will say 8.975 to 10.523. So that's doing it with the calculator. So